Hello and welcome to Mrs. Baker's walkthrough of the guided notes for lesson 6. In this lesson, we are going to learn to convert between two magic triangles. So we've already practiced the mass mole MR triangle, which is the red one here, and we're now going to convert between the red triangle and the blue triangle. So if we're talking about gases, we can convert into the gas triangle as well. If you're not sure how the table method works and you are not sure how to use the red triangle in isolation, then please go back and watch that previous video and do the guided notes and the walkthrough first, because this video builds on what we've learnt in lesson 5. Okay, so you can do gas triangles the mathsy way or the chemistry way, the table method, it doesn't matter. We'll go through both here, and one way will work in your brain better than the other way. I suggest that you find the way that works for you and you stick with it. So, carbon monoxide burns in oxygen to give carbon dioxide. If I burned 1 decimeter cubed of carbon monoxide, how much oxygen would I need? So the mathsy way, I would say, use my molar ratio, and I would say I have 2 moles of carbon dioxide for every 1 mole of oxygen. So I've got a 2-to-1 ratio, and we know that equal volumes of gas contain the same number of molecules. So if I had 1 dm cubed, I'd have 1 over 2 because I've got half the amount, which would give me 0.5 decimeters cubed of oxygen. So my answer would be 0.5 decimeters cubed. But if that way doesn't work for you, if you're like, wait, what? Then all you do is you just use the table method, which is so much simpler and easier. You can't go wrong. We put in what the question tells us again. The question has told us that we've got 1 decimeters cubed of carbon monoxide. So we've got a volume of 1 decimeters cubed. 24 is always 24. And then we follow it through. We say 1 divided by 24 gives us 0.0416. And then because we've got a 2-to-1 ratio on our molar ratios, we must do 0.0416 divide by 2. We keep our calculator value, we just divide it by 2, and that gives us 0.020. Keep the calculator value, times it by 24, and that gives you 0.5 moles per decimeters cubed. So you'll see you get to exactly the same answer as you did with the mathsy method, but if you like the table method and that way works in your brain, you just use that. Okay, so what volume of oxygen is needed to burn completely 100 centimeters cubed of propane? Again, we can use the mathsy way. The mathsy way would be to say we're looking for the volume of oxygen to burn 100 centimeters cubed of propane. So we're going to say our molar ratio is 1 to 5. And then we're going to say we've got 100 centimeters cubed to 500 centimeters cubed. So it would be 500 centimeters cubed. But if you prefer the table method, we can say we've got 100 centimeters cubed. 24 is always 24. So we do 100 divided by 24. That gives us 4.166. We do 4.166 times by 5 because we've got a ratio of 1 to 5. Keep our calculator value times by 5, and we've got 20.83. Keep our calculator value again, times by 24, and that will give us 500 centimeters cubed. Same way, but one's the table method and one is the mathsy way. Okay, so hydrogen and oxygen react according to the following equation. What volume of oxygen is needed to complete the combustion of 500 centimeters cubed of hydrogen. So what volume of oxygen? 500 centimeters cubed of oxygen. We can say we've got a 2-to-1 ratio. So if we've got 500 centimeters cubed here, we've got 500 over 2 over here, which gives us 250. Not even I need a calculator to do that. So we have 250 centimeters cubed. But if you don't like the messy way, we just plug it into the table and we say we've got a volume of 500. We divide that by 24 to give us the number of moles. That gives us 20.83. If I've got half the number of moles, I've got 20.83 over 2. Divide by 2 gives us 416 moles. Times that by 24 gives us 250 centimeters cubed. What volume of carbon dioxide is produced by the complete combustion of 1 decimeters cubed of butane? Okay, looking at the volume of carbon dioxide, and we have the complete combustion of 1 decimeters cubed of butane. The Massey way is it is a 2-to-13 ratio. Can we simplify that down? We could say 1 to 7.5 if we wanted to, or we could just keep it at 2-to-13. So if we've got 1 decimeters cubed of that, then we've got 7.5 decimeters cubed of that. If you don't like that as a ratio, you just plug it straight into the table method again. Oh, we're looking at oxygen, not carbon dioxide. Please excuse me. Let's take that off. The Massey way is actually a 2-to-8 ratio. Read the question, Mrs. Baker. So 2-to-8 can be simplified to 1-to-4. So if we've got 1 decimeter cubed of that, we've got 4 decimeters cubed of that. Let's put it into the table method just in case. So we've got 1 decimeters cubed divided by 24. 1 divided by 24 gives us 0.0416. We can do divide by 2 and then times by 8 if we wanted to. That gives us 0.166 recurring. Times that by 24. And that gives us 4 decimeters cubed. Calculate the volume of oxygen gas at RTP in these different amount of moles. For that, you are just going to use your vol mole 24 triangle, and you're going to say moles is 10 times 24. That gives us 240 decimeters cubed. Remember, in order for the magic triangle to work here, all volumes are in decimeters cubed. And if they're not, we need to convert them into decimeters cubed. So we've got 0.7 here. We do 0.7 times by 24. That gives us 16.8 decimeters cubed. 1 times 24 gives us 24 decimeters cubed. And last but not least, 0.1234 zeros and a 1 times by 24 gives us 0.00024 decimeters cubed.